Welcome to the Year 2 book. This is exercise 1G, question 7 on partial fractions. Now it's asking us about finding these in partial fractions, but it's mentioning factorising the denominator rather than doing any algebraic division. So we're going to do it without doing any algebraic division at all. Okay, the first thing is, let's do question A, and I'm going to call this one f of x. Okay, and we'll look at question B afterwards. So question A requires us to factorize the denominator and process it from there. So what I'm going to do first is write that f of x, okay, so question A, f of x is equal to 4x squared plus 17x minus 11, and all of that is divided by x plus 4 times x minus 1, which of course is the factorization of that denominator. So that's a starting point. And what I've got to do now is set that equal to the partial fraction form. Now, what you've got to do is recognize this process. If it's a proper fraction, in other words, the highest power of x on the top is less than the highest power underneath, then you simply would write it as a over x plus 4 plus b over x minus 1. Because they're the same power, they're both x squareds, then it's an improper fraction by a degree of 1. And so we put a plus b over the first factor, which is x plus 4, okay, plus c over the second factor, which is x minus 1. Okay, and that's the form that the algebraic partial fractions will take when we finished. Okay, and we've now got to set about finding the values of a, b, and c. So what I'm going to do now is follow that through with the next step, which is to say that if that's the case, then I've got to now put all of these over a common denominator of x plus 4, x minus 1. Okay, so I can therefore say that a times x plus 4, x minus 1, okay, plus b times just x minus 1, and c times just x plus 4, okay, that must equal the numerator of the original fraction, which is 4x squared plus 17x, take away 11. Okay, and what I'm going to do next is I'm not going to multiply all that out, because although it wouldn't actually be very difficult to do it that way, but I'm going to do the substitution method. And I'm going to say, right, let's see what happens when x is 1, because I'm going to cause this term to be 0 because of this here, that's 0. This would also be 0, so I'd be able to work out c. So I'm just going to say here that x equals 1, okay, implies that 0a, a times 0, perhaps I should do it in the same order, a times 0 plus b times 0, okay, plus c times, now it's x plus 4, which is 1 plus 4, okay, and that's equal to 4 times 1 squared, okay, plus 17 times 1 minus 11. Okay, now I am writing every detail down here, and I think you wouldn't need to quite go into as much detail. You could have gone straight to perhaps the next stage, which is that 5c equals, well, this comes to 21 minus 11, which is 10. 5c equals 10. Therefore, c equals 2. Okay, and for x equals -4, I'm going to be able to eliminate the a term and the c term in order to find b. So I'll do this in a bit more of a streamlined way. So I could say that b times -4 minus 1 equals 4 times -4 squared plus 17 times -4 minus 11, and that gives me that -5b, okay, equals -15, and therefore b equals 3. Okay, so I found b and I found c. I haven't found a, and there's no substitution that will enable me to do that. However, I can look at this and see that the only x squared term I'm going to get is ax squared from this bracket multiplication here. I'm not going to get any x squared terms involving b or c or anywhere else. So I can confidently say that ax squared equals 4x squared. I'm just going to put ax squared ... equals 4x squared, just to show that I'm only looking at that part and I've recognized that that's where the x squared term comes from, which implies that a equals 4. Okay, so I've now established the values of a, b and c, so I can conclude by saying that f of x, my original expression, can be written as 4 over, sorry, not 4 over anything, just 4, plus 3 over x plus 4, and I've got 2 over x minus 1. Okay, and that is the algebraic partial fractions for f of x. Okay, so quite easily done without too much heavy algebra, and no algebraic division necessary in order to do what the question was asking. Now, the part B has a lot more to it, and it will take longer to do. So we'll make a start on that on the next screen. If you want to pause it and make any notes on that one, please do. Otherwise, I'm moving on now to part B. Okay, here we go. Right, now in part B, we have a slightly different situation because this fraction is more top heavy or improper, if you like, than this was, because it's a degree higher. Well, that means we do this. I'm just going to call this g of x. Let me just bring that to the front so you can see, like that. Okay, so this is equal to g of x, and that's what we're working on now. Okay, now. Okay, so g of x for part B, g of x is going to be written as x to the 4 minus 4x cubed, okay, plus 9x squared minus 17x plus 12. It's a full quartic with every term there. There's no missing terms. Okay, and the factorization of that, well, the denominator, you've got a common factor of x, okay, but you've also got a quadratic then of x squared minus 4x plus 4, which of course is the perfect square of x minus 2. Okay, so that's what you've got. And because of that, you're going to have a repeated factor to deal with as well. But the first thing is to set this up correctly. And because this is a degree higher than the than the expression on the bottom, we need to begin it with this, ax plus b. Okay, then we introduce the three partial fraction bits relating to the three factors. Okay, and it's going to be c over x, which is not a repeated factor, plus d over x minus 2, plus e over, we can't say x minus 2 because it's a repeated factor, so we have to introduce x minus 2 squared. So it's starting to look quite complicated, and there is quite a bit of work to do with this. Okay, but that's our starting point. Now this next bit, you have to be really careful here, because we've introduced this ax plus b bit. So what we're going to do now is write the whole thing over a common denominator of x minus 2, x minus 2. And this is the way that we do that. So I'm going to write ax plus b, okay, because that's a bit I've added in, if you like. All right. And all of that has to be multiplied by x and by x minus 2 and by x minus 2. Okay. And then I've got to have the c. Now at the moment I've got the x, but what I need to add to the c or multiply the c by is x minus 2 all squared, or x minus 2x minus 2. Okay, because I've already got the x underneath. With the d, I've got to have d, and I need an x and an x minus 2. So I've got dx x minus 2. Okay, and with the e, I just need to have the x, like that. And all of that would equal the numerator of this. So it's the whole thing, x to the 4 minus 4x cubed plus 9x squared minus 17x plus 12. Now, we could approach this in a number of ways here. Well, two main ways. One by substituting, and the other by multiplying out the whole thing on the left. There's quite a lot of multiplying out to do. I'm going to start by substituting, and on the way we will find at least some of those variables, a, b, c, d, and e. Okay, and we might be able to minimize the extra work we need to do afterwards. So by putting x equal to 0, okay, I'm going to eliminate quite a few of those terms. So let's just put x equals 0 here. Okay, and if x was 0, the whole of this first term would be 0 because of that x there. This term wouldn't be, okay? This term would give me c times 0 minus 2, which is minus 2 times minus 2, okay, which is going to be 4. So c times, well, it's going to give me 4c, okay? And this term's going to be 0 because of the x on its own here, and this term's also going to be 0. So in fact, I can get c by saying that 4c equals whatever this is when x is 0. Well, that's easy as well, of course, because that's 0, that's 0, that's 0, and that's 0. I'm just left with 12. So 4c equals 12, okay? Therefore, c equals 3. So I've already got one of the numbers I need. Okay, I'm just going to highlight these now because we lose them then in all the other bits we do. Okay, so having found C, let's see if we can find one of the others by doing another substitution. Well, the next substitution, the only other one that could be useful, is x equals 2. Okay, so if I do x equals 2, okay, it's going to eliminate something else. So let's see what happens. When x equals 2, the first term here is going to be 0 because any of those brackets will be 0, so the whole thing's 0. This term's going to be 0. This term will also be 0. So the only term I'll be able to get is this one here. So I would get e times 2, or 2e, okay? And 2e is going to equal, well, 2 to the power of 4. Okay, this time I have something from each of those terms, minus 4 times 2 cubed, okay, plus 9 times 2 squared, minus 17 times 2, okay, plus 12. Okay, and all of that means that 2e equals, if you work all that out, it comes to minus 2. Okay, so that you can do that on the calculator or work it through, but it comes to minus 2. So 2e equals minus 2, which implies that e equals minus 1. So we've now found another one of our variables that we need. Okay, so that's 2 out the way and 3 to go. Now, the next thing I'm going to look for is, yes, I'm going to try and find a next. Because you see, if you look through the whole of this here, the only x to the 4 term is going to come from here. Okay, there's no x to the 4 term going to involve c, d, or e, okay, or even b, because b times x times x times x is x cubed. So the only quartic term is a x to the 4, which is going to come from a times x times x times x times x. So I can say that a x to the 4, okay, without doing any more than that, is equal to 1x to the 4, okay, because that's what I've got on the right hand side, and therefore, of course, a is 1. Okay, so I've now got 3 of my 5 unknowns. Okay, so I'm just going to highlight that one as well. Still got to find B and D. Okay, well, I think at this point I'm going to have to do some of the multiplying out. Okay, and let's see how much of it I'm going to need to do. So the next thing would be to start multiplying out the first part, and I'm going to put the x with the ax plus b. So I'm going to go ax squared plus bx. Okay, So I'm merging that x there with the first bracket. And I'm going to multiply that by the quadratic, which is the x squared minus, so x squared minus 4x plus 4. Okay, so I've multiplied that partially together. Then I'm going to have c times x squared minus 4x plus 4. Okay, and I'm going to have d x squared minus 2dx. Okay, and then I'm going to have my e to the x. Sorry, not e to the x, e times x. Okay, I'm just going to leave that like that for the moment. We've got the rest of it over here. And I'm just going to say that this then equals, well, you've got 6 terms to come out of here. So you're going to get ax to the 4. Okay. You're going to get plus, and you're going to have b well, I'm going to do it more in stages, I think. So ax to the 4, okay, minus 4ax cubed. So basically I'm going to get 6 products out of the first pair of brackets, minus plus 4ax squared. Okay. Then I'm going to get bx cubed. Okay, then I'm going to get minus 4bx squared. Okay, now I'm doing a lot of this now that I was hoping to avoid, and then of course you would ask the question, well, I could have got all of the variables from this, but I still think you'll find it's easier to get most of them from the substitution method if possible, and that's going to give me 4bx. Okay, so those 6 products there come from this first bracket. Gets a bit easier now because I've got cx squared. Okay, minus 4cx plus 4c. Okay, and then I go on to the d terms, which are already done for us, plus dx squared. Okay, minus 2dx plus ex. Okay, now if I can start grouping them together, I might not need to do all of it, but I can do some of it, and I can say that I've got x cubed terms. So I've got ax to the 4. We've already dealt with the a, so we know that's 1. But then I can do the b minus 4ax cubed, okay, plus b minus 4a, because they're the only 2 terms that are x cubed terms. Okay, and then if I do the x squared terms, I can stop after that, because the x squared terms are c plus d, okay, c plus d plus 4a minus 4b. There's 4 of them. Okay, you can find them in the thing above. Okay, and those are the x squared terms. And then I would go on after that, but I don't need to. Okay, because at this point I can see that b minus 4a, okay, so b minus 4a, that's the x cubed term, I can match to this, which is minus 4. okay? But I know that A is 1, so B minus 4, okay, is equal to minus 4, which means that B is 0, okay? And that's a perfectly valid answer. That often is the case. So there isn't a B term, but there could have been. Okay, so we had to include it. Finally, we've just got to find one more, A, B, C, D. We've got to find D. So if we use this, we now know what C, A and B are, so we can easily find D. Okay, so from all of that we've just done, we can have C plus D plus 4A minus 4BX squared. Okay, well, we've got C is 3, so we know that 3 plus D, which is what we need to find, plus 4A, which is 4 lots of 1, which is 4, okay, minus 4B, which is 0. We know that all of that is equal to the x squared coefficient, which is equal to 9. Okay, well, 3 plus 4, which is 7, plus D is 9. And that therefore implies that D is 2. Okay, so we've now found our 5 variables. So what is our answer? Well, we just got to put it all together now. So g of x equals, okay, ax plus b. Well, that's easy. That's 1x plus 0, which is just x. Okay. Plus c over x. Well, c was 3. Okay. And d over x minus 2, which is equal to plus 2. Okay, that should be a plus. Plus 2 over x minus 2. And finally, minus 1, because e is minus 1, so it's minus 1 over x minus 2 all squared. Okay, and that is the partial fraction version of the expression here. Okay, so quite a lot of work to do. We didn't have to completely process this, but we did have to do quite a large amount of it. But as I said, it's still easier to find these through the substitution method first. Get some of these variables early on, and that will help you in solving the final few here. Okay, so I hope that was helpful and gave you an insight in how you could do these questions without necessarily needing to do the division as well. Okay, I hope that was helpful. Take care.